Okay, so we're going to start right now. Good morning, everybody. The second FIRA is about to begin. Please again, join your seat. And before letting Émeric Barthès speak and introduce the event, I'd like to remind you that simultaneous translation service is at your disposal. It goes from English to French and French to English. Second point, Twitter. Feel free, please, to use Twitter, tweet, and please use our hashtag, which is quite simple. It's FIRA to 2017. Okay, now this second FIRA can start, and Émeric Barthès, NIO's co-founder and CEO, is welcoming you.
Good morning, everybody. Thank you, Isabelle. First of all, a very warm welcome to you all here in Toulouse. I would like to open the conference with a very short and simple statement. Thank you. Thank you all for coming to the second edition of FIRA. Some of you have traveled a long way, and we are very happy to have you all with us. Also, a special thank you to FIRA partners. This year, over 40 institutions, companies, journalists, and ambassadors have helped us make the forum possible, and we really can't thank them enough. Before I leave the stage to make room for our speakers, I would also like to express our special gratitude to Toulouse Métropole for welcoming us here in the scientific heart of Toulouse at the Quai des Savoirs. The location wasn't chosen by accident. I mean, today, we are going to talk about agricultural robots, which means robotics, which means science. We are here together in this amazing and prestigious place to enable science, and especially robotics, answering some of the biggest challenges agriculture is facing today. Together, we want to move forward and lay the groundwork for the sector of agricultural robotics. Together, we are going to build this sector and share our ideas, thoughts, and feedback during this new edition of the International Forum of Agricultural Robotics. Today, I think I can say something. I can say that this event, this FIRA, is a huge success. There are nearly 500 people gathered here, more than double the participants we had last year. However, the two coming days will only be truly successful if we get the dynamics of the agricultural sector going. We aim to make agricultural robotics more democratic and create a close-knit sector where every stakeholder participates in the new and upcoming agricultural revolution. Thank you. It's time for me to leave you. I really hope you will all enjoy the FIRA. And let's turn this event into an international crossroad of science, robotics, and agriculture. Have a nice day. Bye.
Thank you very much, Émeric. Now we are beginning with the first part called Why Robots Come to the Farm. It will be animated by Isabel Baez-Betancourt, who works for several Spanish ag magazines. Please come to the scene. And with you, Simon Blackmore, Philippe Janot, Maët Leland, and Luc Valentin. Please welcome them very warmly.
Well, bonjour. Désolé, je ne parle pas français, so I will continue in English, if you don't mind. Thank you very much for coming here. I will be conducting this debate. I'm overwhelmed with this amazing audience. It's a lot of people. I didn't imagine it was going to be like this, so I will try to do my best. We have a really difficult task today, which is to answer this question, why robots are entering our fields. It's quite the question. So to help us to find the answer, or perhaps it will be more than one answer, I guess. We have our speakers today here with us. Let me introduce them. It's Professor Simon Blackmore from Harper Adams University. Philippe Janon from Vet Areosup. We also have Luc Valentin, farm consultant in the USA, and Maët Leland, that coordinates the Bretagne Sud Experimental Research Station. Okay, so with no further ado, I would like to ask Mr. Professor Blackmore to begin with his presentation, please. Thank you.
Okay, well, thank you very much, Isabel. Bonjour, good morning, everybody. It's a great pleasure to be here. I think this is the first time I've had the opportunity to talk to so many people in agricultural robots. This is a wonderful turnout that we're getting here, so I congratulate the organisers for doing this. So I'd like to tell you a little bit about the work that I've been doing over quite a number of years now to develop a complete system of agricultural robots. It still is very much at the cutting edge. Things are moving very quickly. But I'd like to go through some of the ideas and designs and opportunities that we've got to help to make agriculture more efficient than it is at the moment. So I come from a small university in England called Harper Adams University. It specializes in agriculture. We set up the National Centre for Precision Farming, and we do a whole range of different research projects, including drones, autonomous tractors, laser weeding, robotic seeding and spraying, phenotyping, autonomous mowers, strawberry harvesting, and the hands-free hectare. We haven't got time to go through all of these, so I'll just show a selection of them for you. The UK government has changed tack recently over the last maybe 15 years. Very little research money has gone into agriculture, but we've now got 4 new centres in the agricultural sector, and one of them is the Precision Innovation Centre, which is a private company at my university. And there are hubs in Scotland and at Cranfield University. But we have 27 instrumented farms now and 130 commercial collaborating companies. So the topic of today then really is to try and come up with a vision of what agriculture is going to be like in the future. And as we look forwards, we can also then look into the past and look at our current agricultural system. And although every farmer will know that they are doing the best that they can, they are good farmers, I can see many weaknesses in our current system. And one of the main areas is that the current agricultural practices use too much energy in all its different forms. And there are new drivers for change in the agricultural sector. We need to come up with more sustainable food production. Farmers need to be able to make more money, to be able to make a living wage, and we have to then look after the environment. So I believe that we need to develop a more flexible agricultural production system. Many farms and fields can be of this sort of size, the sort of prairie-type farming, but I believe that the current mechanization system is more like an industrial production line, where we are only interested in maximizing the yield. But many industries have moved over into flexible manufacturing, where we have a much more dynamic set of tools that allow the managers to be able to do things in different ways. It becomes more information intensive, but we can then be able to maximize gross margins, manage risk, and minimize environmental impact if we then use automation. Again, if we look at how machines have developed over the past maybe 50, 60 years, we can see that it has been linear development. It's been getting bigger all the time. There's a very good reason for that, and that is through economies of scale, because one of the major costs is the person sitting on the tractor. And if we can then increase the production of that person, then the investment then makes sense. But machines have now reached their maximum size. Here we've got a picture of a modern tractor and a combine harvester here. And this is being loaded onto railway wagons. And this then has to fit through a railway gauge. Now, the machines are designed to fit through this railway tunnels now, so they cannot be made any bigger. They've now reached the maximum size. But on the other hand, that gives us the opportunity to be able then to look for other forms of efficiency. So big tractors and big implements give us increased work rates and economies of scale. I believe that they've now reached their maximum size. These big machines are good for big fields and big farms, but I believe that small to medium-sized farms and fields have the greatest potential for increased production. We're all interested in agriculture. We all want to be able to feed the planet. Where is that extra production going to come from? What we've seen with precision farming over the last 20, 30 years is that very rarely does precision farming increase yield. We can reduce the cost of production. So where is this extra yield going to come from? And I believe that it's not necessarily going to come from the big farms and the big fields. I think it's going to come from the smaller farms and smaller fields that have not been able to take advantage of economies of scale of the big tractors. So the small fields and small farms are not as efficient as they could be. But with the advent of robotics, I think that these small farms and small fields can produce significantly more and become much more viable enterprises. Now, I'm an agricultural engineer and I like big tractors. Give me a day off, I'll go and do some recreational tillage in the fields, black smoke coming out the exhaust pipe, I will be very happy. But I asked this question to the farmers, obviously the tractor is stuck here, but why is the tractor stuck? Some farmers will say you have a crazy driver because you shouldn't have gone there in the first place. Some farmers will say it's the weather, meaning that the soil is soft because it is raining. I say neither of those things. I say the problem is with the big machine. You cannot change the soil, you cannot change the weather, we can change the tractor. So at the moment, one size fits all, boys' toys, big boys' toys. I'm sure some of you were maybe at Agritechnica last week, and you will see the big machines there. But I believe that small, smart machines are just as much fun and are just as much interest to us. We cannot change the soil or the weather, but we can change the tractor. And so, of course, that's why we are here today. We are here to discuss this new form of mechanization. The big machines, although they solve lots of problems, they also cause lots of problems. Here we can see sugar beet growing, and here we can see a compaction layer in the soil that is then due to the big machines in the first place. I now estimate that 90% of the energy going into cultivation is there to repair the damage caused by the large machines in the first place. So why do we do it? Repeated damage year after year. Every year we damage, every year we repair, then we damage, then we repair. This is crazy. The economic cost of compaction in the UK alone is 0.4 billion pounds per annum. Huge amount of money. And it doesn't need to be there. That is waste. That is due to the inefficient system. If we don't damage the soil in the first place, we don't need to repair it. And in fact, if you look at where we find the best soil structure, it is by the hedgerows, by the field boundaries, in the forests, because the natural flora and fauna create a good soil structure for us naturally. So if we allow these natural processes to occur, then we will get the right environment that we need. So we need to move towards controlled traffic farming for the big machines and ultralight machines for the robots. So I believe that there are 4 phases to this agricultural production system. We have seeding and cultivation, which I now call establishment. We have then scouting, where we've got machines that can go in and take measurements. We then have crop care, where we can do things to the plants and the soil and the field. And then we have what I call then selective harvesting, and I'll go through some examples of these. So a robotic seeding system needs to be ultralight, zero draft force. There's some very radical ideas coming in here. I haven't got a chance to go through explaining all of these. But if we are going to change the system, then let us make sure that we take advantage of the technologies that we've got to be able to give the farmers what they need, but in the most efficient way. I challenged my students a couple of years ago to come up with an ultralight machine. So they bought a ride-on lawnmower and then robotized it. And we took it out in February, a few years back, where the soil is very wet, at what we call field capacity. And where I stood out in the field to have a look at the tractor, my foot sank into the soil. It was so soft. But the following day, water had gone on top of the soil. But where the tractor had gone across here, there was no compaction. So that's allowing these robots to go out into the field when a normal tractor would not be able to go into the field at all, which then is allowing farmers to do things that they can't do now. So crop scouting, where we can use unmanned ground vehicles. We can also use aerial vehicles, a lot of drones. People are looking at different aspects of drones. We've set up the Agricultural Drone Center, where we're developing what we call second-generation drones. So first-generation drones are flown with joysticks and with cameras and LiDAR. The second-generation drones then actually go and do things like spraying and seeding and sampling and so on. So we're developing some of these systems with different companies, but we do need to change legislation. What we are doing in the agricultural robot area is to utilize technology that's not been utilized in agriculture before. But a lot of agriculture is tied up in terms of legislation. It's stopping us. In the UK, we're not allowed to use spray drones. So we have to lobby the governments, all of our governments, to be able to allow us to use these technologies. Some of you may be aware that glyphosate has been got a renewed license for 5 years. Let me make a very important point to you. There is nothing wrong with glyphosate. We should ban the dumb machines that are applying glyphosate in the wrong places. Think about that. The problem is not with the chemical. The problem is with the way in which the chemical has been applied. So we need our work to come up with smart sprayers. I will show examples of this in just a moment. So here we have a scouting robot. for vineyards, with thermal cameras for irrigation status, multispectral cameras for nutrient status, and LiDAR for canopy. Here we have a sub-canopy robot working with some of the space sector people. Here we can see 1 and 2 hyperspectral cameras, omnidirectional cameras, and 3D cameras, being an instrument platform to go underneath the crop to be able to take measurements. We've then got an aspect of crop care, robotic weeding, so we're working with one of the major vegetable growers in the UK with lettuces, and here we've then got the weeds. Hand weeding, maybe some of us like to eat organic foods where we don't have any chemicals used on them. This costs £2,000 per hectare to pay people to do this work. 80% of the grass weeds in the UK are now herbicide resistant. We have a big problem with blackgrass. Don't ban glyphosate, ban the dumb machines. The chemical companies are not investing in new active ingredients. They're not developing new active ingredients. It costs so much money, $250 million in 10 years. But let's think laterally. If we have the ability to apply chemical only onto the leaf of the weed, there are many active ingredients that are available to us that we can now use. So we are working with the chemical companies to develop new machines because we have to have a symbiotic relationship between the chemicals and the machines that apply the chemicals. But there are other methods of being able to control weeds. So mechanical weeding, microdroplet, and laser weeding from 3D imaging.
Okay. Weed killer take 2. We have to demonstrate our weed killer. It's an intelligent micro sprayer which can detect the placement of weeds and apply herbicides directly onto the weeds. It consists of this tunnel inside which the plant should be moved. On top of the tunnel we have a camera, and behind that camera we have a microspray, the black box here, which have 7 distinct nozzles which can apply herbicides individually. And now let's see how it works. We place the plant in this holder and then start the robot. And now it's moved into the tunnel, and on this screen we can see what the camera sees. Now you can hear that herbicides have been applied. And on the plant we can see that the blue stuff, which is the colored herbicide we have applied.
Okay, so we can see with some straightforward technology that most of it is which is commercially available now, can be able then to save 99.99% of the chemical. And that is just through this new concept that I'm developing called intelligently targeted inputs. It's what you and I would do in our garden. If you've got a weed in your garden, you don't go and spray your whole garden. If you've got a weed, you go and pull that one weed out, or you put chemical onto that one weed. It's not rocket science, it's what you and I would normally do, and that's the approach that we're taking with these robots. So here again is machine vision, augmented video of weed recognition. And from this then we can identify not only the weeds, but also the little growing points, the meristems of the weeds. And if we then got that, we can apply a laser beam onto the weed to be able then to kill the weed. So the project hyperweeding in the UK has just finished. So we've got our lettuces, we can then identify where the weeds are, and we can then use lasers to be able to kill the weeds. So only need a very small amount of energy, and we can also spray as well. So this one is then identifying where the weeds are and then just putting chemicals onto the spray. Here we can see the machine working in real time. The flash is then the multispectral wavelengths light that we're then using, and we can see where the lasers are going, and we can see some of the results from the tests of using these two different systems. So here's one of our autonomous tractors being able to change its navigation from RTK to LiDAR, so it identifies the posts and can steer through. We've developed this tractor that I believe now has got all of the requirements for legislation and health and safety. So we have 7 levels of safety on this tractor. And I think that that can work in a commercial environment now with the current legislation without having to change anything. Which finally brings us on to the concept of selective harvesting. So between 20 and 60% of harvested crop is thrown away at the point of harvest, which is terrible waste. Why is that? I'm afraid, ladies and gentlemen, you are the problem. I am the problem. When we go to the supermarket, if you see some lettuces or tomatoes, you pick the best one. You don't pick the worst one. This is human nature. The supermarkets pass this back to the farmers. So they will not buy anything from the farmer if it's too big or too small. And so, therefore, the farmers have to grade the products, and a lot of it is then wasted because it's too large or too small. But the concept of selective harvesting is, again, the same as you do in your garden. When you have your tomatoes growing, you go and pick the one tomato that you want. So if we put the same behavior into the robot, then we can not only pick the products that we want, but we can also grade at the point of harvest. We can add value to the products before they leave the farm. So we can have pre-harvest quality and quality assessment to do the grading and packing at the point of harvest, and be able then to, on the work that we did with strawberries, I'll show you in a moment, where each strawberry can be graded for its sweetness, its ripeness, its shelf life, and be packed at the point of harvest. So here we have one of the concept machines, and the front part is the harvester. The back part is what I now call the automated logistics. When this one is full, it can run back to the farm, and another one can come and plug itself in, but underneath here, it's then got the water, the fuel, the batteries, whatever is needed to keep the front part working. So here we've got a little bit about the robotic strawberry harvester, where we use stereo vision to grade the strawberries and to work out where the stalk, the peduncle, is. We can then go through the crop to work out where the ripe strawberries are, and the robot can then go in and be able to pick them. And as we've got control of each strawberry, rather than just dropping it, we can then put the near infrared onto it to be able to work out this one is a sweet one, this is not a sweet one, this is a ripe one, this one goes to this supermarket, this one goes to another supermarket. So we can put value into these products rather than being mass produced. They can become high quality products straight away. So there's been a lot of interest around the world for a project that we're running at the moment called the Hands-Free Hectare. This is where we are growing 1 hectare of crop without anybody ever going into the field. The crop was surveyed by drones, sampled, soil sampling with the robots. The normal operations were done by tractors and combines that we had robotized. And we did get 3.5 tons of barley that we're now going to turn into robot beer, which should be interesting.
We have modified our tractor with the autopilot from a drone. So they are conventionally used to plot waypoints around where you want to take your aerial photography from. We've adapted that system to control our tractor. We've interfaced the human controls with actuators in the steering wheel with an electric motor to convert the signals the autopilot produces to control the tractor.
Okay, so in conclusion, I think that as the title of the conference is that agricultural robots are here, I think that is exactly right. We are now at a new phase of agricultural robots. They are moving from academia into the commercial sector. I'm aware at the moment of 12 agricultural robot startup companies. And I think that now is the time where we need to think about these things in different ways and be able to let the farmers take advantage of all the opportunities that we've been able to create. I'm currently working with 2 startup companies looking for capital to be able to develop them. I think that they are going to be very disruptive. They're going to be disruptive to the farmers because you need to think about farming in a different way. It's going to be disruptive to the machinery manufacturers and obviously to the investors as well. But it's worth it because of the benefits from it. The increased yield will then come through improving smaller fields, and collectively now we're designing these new systems and trying to understand the implications of it. Each new technology that comes along then gives us a chance to think about what the implications of that is going to be. And I'm always interested in partnerships, so very pleased to have the chance to talk to you today and be very pleased to have discussions with any of you after that. So with that, I say thank you very much for your attention.
Thank you very much, Simon. It's been really amazing to hear about all the opportunities that these new technologies can bring us to improve and to get a more efficient agriculture. So we are now moving to a new topic, which is what are the challenges for farms in the digital machine age? And Philippe Genot will help us to know more things about this.
Bonjour à toutes et à tous. Je m'appelle Philippe Genot, je suis enseignant-chercheur en économie rurale à Clermont-Ferrand, dans une école qui forme des ingénieurs agronomes. Je m'intéresse particulièrement à la prise de décision en agriculture, au comportement des agriculteurs et à l'évolution de l'exploitation agricole depuis, sur longue période. Voilà, donc je vais reprendre peut-être un des points de conclusion de Simon Blackmore quand il dit « Robots will be disruptive but will have significant benefits ». Et donc mon propos va s'appuyer sur un questionnement en fait. avec l'idée d'imaginer ce que peut être le futur de l'agriculture numérique et les conséquences peut-être de cette agriculture numérique, c'est peut-être justement la fin de l'autonomie de la décision des agriculteurs. Et c'est ça que je voudrais aborder avec vous en 10 minutes. Je commence mon exposé par
I will start my presentation with a sentence which I've taken from the magazine Chambre d'Agriculture, the General Assembly of the Agricultural Chambers. In this article, the president of these chambers was saying, well, we tested a drone on 4,000 hectares, and finally, our final objective somehow is to transmit all the data obtained by the computer on the tractor. It is to use all this information to undertake fertilization actions, treatments, which are going to be programmed on their own at the right dose, in the right place, on the microplot. So what he was saying, in fact, is I find it very interesting the fact that the machines are going to decide where to apply the right dose. Now, the question which is very important for me is, now what about the farmer in this world of machines? What is becoming of the farmer? And I'll go back in time to what we call the first age of machines. That started with the creation, the invention of steam engines in 1755 or 1760. From that time on, we concentrated energy in any given place. We did not depend on elements anymore. And in the agricultural sector, in the last 35 or 40 years, since the 80s, this is obviously illustrated by massive investment in technologies in order to have productivity gains. Here on this overhead, we can see the investment effort of cultivators, of growers in France between 1980 and 2015. Overall, and then we have to look at the chart and this curve down here, we remain at an index of 100. That is the investment in billions of euros. Corrected by the inflation rate. So we can see that we maintain the investment effort, which is about 10 billion euros every year. 10 billion euros invested in the field of agriculture every year. So the total asset must be 120, 130 billion euros. So this is quite a lot. So this is to improve productivity gains, and we see it translated in this red curve for the same period of time. The productivity of the farmer's work is multiplied by 3. So we produce a little more. We produced 25% more products with 3 times less workers. And all this to maintain profit, to maintain the farmers' profit, or at least those farmers who are engaged in this approach to lower their production costs. Then we come to the second age of machines. So what are the new levers for productivity gains? We could say that this is the digital agriculture which has just been presented. So this is what we call the second machine age. Brief Johnson and McAfee are the two research scientists. They wrote a book on the second age, on this second machine age. And in agriculture, this means robotization, the collection of massive data with all sorts of sensors, and the processing of this massive data with the specific algorithms by the use of artificial intelligence as well, harmonizing all the machines as well to create standards so that the machines can speak to one another. So this second machine age, in the end, is quite interesting because it poses three main questions in my eyes. Three main questions on the effects of this technology on decision-making, on the organization of agriculture, on the production structures, and on the advice to be given to farmers. So my first question is, in the end, are new technologies leading to a loss of autonomy in the farmer's decision-making? Now, what is becoming of decision-making when it is the algorithms that make the decisions? If we are based on Herbert Simon's work, how to make decisions. Well, the decision is that we collect information, we process this information, and then we make a decision on the basis of it. Now, from the moment in which the collection is done by machines, by computers, that treatment is done by artificial intelligence. Now, what is left for the growers? What is left for the farmers? The farmers will always have the power to press a button, the button enter. But what about the responsibility of the farmers? Are we not in a world in which the machines are going to make better decisions than the human beings? The second question which is raised, perhaps there are Vitirover people in the room, but I've taken this interesting example. How can the farmer's job can evolve with these technological innovations? This is a company which is selling a service. You are a farmer, you don't buy the robot, you don't buy the technologies anymore, we just rent. You buy a service, a maintenance service of your plots to spray pesticides or whatever. So the question is, who is going to drive the machine? Who is going to who is conducting the farm holding? Is it the farmer? Is it the technician of the machine? Because I have like a shepherd with different robots. The shepherd lets its robots loose in the plots. Then he takes them back and deploys them somewhere else. So who is conducting? Is it still the farmer? The farmer, is he not changing jobs now? Is he's becoming just a manager of a service? He doesn't act anymore. He delegates a lot of activities. So this is probably questioning the whole job of the farmer. Third consequence, which is important, it's around advice service. In France, there is a very highly developed structure, advice to be given to farmers, innovations to be presented. So what is advice becoming in a world in which data is analyzed, stored by machines, processed by machines? In the end, are we not creating a world in which agricultural equipment is going to take control? They're going to propose algorithms, process the data, and start making the decisions in the place of the farmer. So I always ask these questions. Now, the guy who controls dairy farming, what is becoming of his job in a world in which there are robots and tools to control all the chain, all the production chain, like the animal's temperature, for example? Now, what is advice becoming in this world? Isn't there a risk? We always talk about retail trade, and now the machines are they not going to take control of the farm holdings, and the farmers are just controlled by this industry? So as a conclusion, who decides? Is it the farmer who is still going to make decisions about his farm? Is it the machine? Is it the whole sector of agricultural machinery? Now, for the moment, and I'm not there to say let us stop that movement, but what I'm saying is that perhaps there is a risk of losing the autonomy in decision-making, because data collection is done by sensors. Anything to do with actions that is going to be done by robots. At the moment, decision-making is respected, but there is the danger of decision being made by the robots in the end. So all this is a challenge for the job of a farmer. It is challenging the whole issue of education, of training, and it is even challenging for the values in this job. Are we going to end up having farmers who are going to have to obey others? Is a farmer going to continue being autonomous? Or is it just going to become one more worker in a whole production chain? Are we still in the second age of machines? Not totally. Machines are not in full control yet. But it seems to me that we need to debate on these issues, and I'd like to thank the organizers for enabling me to exchange with you and to ask these questions. There should be a critical debate on this digital era and technological era of agriculture. Thank you. Good morning, Maître Leland. I work in the Chamber of Agriculture of Brittany, specialized in vegetable growing. The question is, why are robots coming to our farms? And this is one of the avenues we want to work on to reduce hardness. This hardness is mainly in two activities: weeding and then repetitive cultivating actions. Concerning weeding, the problem is very simple. Vegetable growers have about 50 different types of vegetables. They cultivate them on small surfaces. Mechanizing the work on these farms is difficult. The material, the machines are very costly and not adapted to the size of these holdings. So the time the vegetable growers spend on weeding represent 50% of their work, of their working time. And 9 growers out of 10 complained or suffer from musculoskeletal disorders. So we started a project around work hardness in vegetable growing. This project started 3 years ago now. I will not give you all the results, as I don't have time in 10 minutes, even if I speak fast. This year we decided to make a video clip to present some of the results and which shows our working methods and how we compared our practices with and without robots. And we are offering you this video clip now.
Ce projet, finalement, il est né d'une envie forte sur la station de travailler le sujet de la pénibilité dans les exploitations maraîchères et d'une rencontre qui est le premier robot autonome de désherbage des cultures, mais qui, moi, m'a intéressé.
This is translated in English on the actual video.
Mais aussi en aide à la personne pour tout ce qui est opération culturelle. Dans ce projet, on le teste sur ces 2 modes-là et on teste aussi d'autres stratégies, notamment des stratégies de désintensification des rotations des cultures, où le concept est simple, on cultive moins à l'échelle de la rotation pour pouvoir laisser du temps aux exploitants pour mettre en place des pratiques telles que le faux semis qui permettent de casser les adventices estivales. Dans ce projet, on doit répondre aux questions, finalement, est-ce rentable d'avoir un robot sur une exploitation? Et qu'est-ce que ça change dans nos conditions de travail, dans notre quotidien, à l'échelle d'une exploitation agricole?
avait beaucoup de mal à maîtriser l'enherbement de nos parcelles. Donc voilà, les passages à la main, ça suffisait plus. C'est une création aussi d'exploitation, donc on n'avait pas forcément de matériel adapté et spécialisé encore, on était mal équipé. Donc on a fait le choix d'acquérir le robot. Supprimer pratiquement l'ensemble des paillages, on maintient sur la salade en extérieur et quelques cultures d'été comme la courgette ou voilà sur les premières plantations en serre éventuellement, mais voilà, les 3/4 des paillages ont été supprimés. C'est vrai qu'au début c'était pas évident, faut vraiment s'adapter au robot et on a perdu un petit peu de temps. Bon, c'est pas vraiment de la perte de temps, mais voilà, la prise en main a été pas forcément facile, mais les résultats sont là et sont bien plus efficaces que nous. Et non, on est très satisfait et ouais.
T'as diminué ton stock aussi d'adventistes?
Voilà, on a diminué beaucoup. Comme avant, on avait du mal à maîtriser. C'est vrai que ça regrainait encore, mais là, voilà, on a pratiquement plus de problème. On suit les cultures et on nettoie assez rapidement après les cultures. Et un passage régulier du robot, voilà, ça permet de maîtriser l'ensemble des choses. Ouais.
Au début, c'est de biner, donc voilà, pour essayer de limiter les désherbants, et puis pour la pénibilité aussi, pour nous tracter, et puis faire des interventions sur les cultures comme arracher, ou nous en semence on enlève les feuilles pas mal, on déjupe, on fend les choux, voilà, pour avoir une position de travail un peu plus confortable, pour pas se briser le dos. En positif, du coup le soir on finit, on a pas mal au dos, et le lendemain matin pour redémarrer c'est quand même beaucoup plus facile. Ouais. Après il faut apprendre à travailler avec la machine. C'est comme toutes les machines, quoi. T'es obligé de t'adapter à la machine, c'est pas l'inverse. Donc faut faire avec, adapter les sorties de serre, tout ça, voilà.
D'accord.
Donc ça c'est un petit peu, voilà, il y a des paramètres à prendre en compte. Au début t'es un peu déçu parce que t'as l'impression que ça va être super, ça va marcher tout seul, mais en fait non, faut apprendre à travailler avec, faire ses outils, même par exemple pour les filets dans les boues, on a des filets d'insectes roux, il faut les lever, donc il faut adapter, voilà, faut s'adapter, quoi. C'est un peu le côté négatif, c'est que y a quand même du travail à faire pour s'adapter à l'outil, quoi. Ouais.
Ok.
Of your study and find how robots can help to improve organic crops to be more productive. So thank you. Now, last but not least, we have Luc Valentin, not an American in Paris, but a French in America. He has been living in the USA for more than 15 years, and he will give us the user testimonials. So he can tell us how the robots are doing in your farm.
D'accord, merci beaucoup Isabelle. Donc moi j'ai une dure tâche de suivre ces présentants qui ont présenté d'abord parce que c'est de la
I have the hard task of following the first speakers because they've done research. What I am going to talk about is more or less a practical view of what is being done in the US. It's the trade methods and so on. There is another aspect which doesn't exist in France, is large crops, as Simon Blackmore was saying. Economies of scales are very beneficial for us, very good. But then Also, this enables us to place more specialized people in certain places and to have less costs. I was born in Clermont-Ferrand, not very far away from here. I studied in Pierrepont, very near here. Then I went to the US for an exchange, and I haven't come back. I left 20 years ago. So I'm going to tell you about the farm with which I am collaborating. I know the mindset of the Americans and American farmers. And I will present very briefly the farm holding. In half an hour, I don't have time to give you many details, but I'll give you the main aspects. As always, we talk about environmental protection, about the hardness of the job and the future solutions, automation, robotization. I'll try to find the difference between robot and automated machine. In a way, it's like a continuous curve with more and more intelligence intervening. There we have large plains in the west of Kansas, very wide, large plains, not highly populated at all. This is a map representation of the farm holding from east to west is about 100 kilometers and north to south about 50 kilometers. If you take the small green square on the right-hand side, it represents 60 hectares, to give you an idea of the scale. Now, what are the figures? Very briefly, we have 20,000 hectares, 100 kilometers by 50 kilometers. About 15 people work there full-time with seasonal workers, particularly at harvest time. We store about 30,000 tons in the holding, so it makes it easier and more efficient to manage the logistics aspects. Rainfall 470 millimeters per year, less rain than in Provence. That means to say that it is extensive. We have variation, 0.7 per this year, for example, more next year. So to manage staff and machines is a bit of a headache. Then we buy manure near the farm. We make compost, a sort of compost. We don't add carbon or nitrogen to it. So this is part of our manure. We have very few, we use very few chemical fertilizers. We fatten 1,500 animals as well. So compared to the farm holdings here, it's enormous, but for us it's not big. So how to cope with these big surfaces? 20,000 hectares is a big figure, but more or less is 15 kilometers by 15 kilometers. I went to Google Earth to compare with the Toulouse area, more or less is a whole agglomeration of Toulouse. That means that all the decisions we have to make are on a large scale and cannot be as precise as if we were dealing with a garden. For example, given the size of the farm, to make efficient decisions is not always easy. So in this representation is as large as the Toulouse area up to Vierzon, 250 kilometers of fields on the left, 250 on the right-hand side, plus the Toulouse agglomeration. So that means you need 4.5 hours. But with a tractor, it takes less time. So we have to remember this idea, because for us to find the robot useful, they'll have to be extremely productive on such a large surface area. What methods were used? As Simon Blackmore said, the machines have to be bigger. They are more and more costly, more and more advanced, technologically speaking. To give you an order of magnitude, these are machines that are 9 to 10 meters wide, on 12 rows. We started with 12 rows, and now we are working on 16 rows for this cutting robot. So we can go, we couldn't use this machine here. That means that with this machine we have to work many hours at the wheel before the farmers managed to sow 250 hectares for one seeder. That means that for the same productivity, you would need to sow 2,000 hectares here. So if we manage to reduce mechanization costs, it's because we cover more hectares. Then driving aids are of paramount importance. Paris wasn't made in one day, so at the beginning the machines was used to help the driver, but before it was only aid, but now it has become absolutely indispensable. Then we also try to respect the environment. The entrants we have are not so many as in France. The University of Kansas explained to us that if we do direct seeding while keeping residues, will increase our yield. So that means less operations, less actions, less tilling of the soil, but the follow-up of the soil and of the cultures has got to be more precise. During the whole spring, we follow the plots to see if we have weeds, what type of weeds, so that we can adapt the treatment according to the weeds we have. So if we have, sometimes we decide to, when we see the weeds, to wait a little bit till it's grown, so that it's easier to kill. And this is one critical aspect for me, where I see that robot application can be very useful on a large scale. We have different levels of automation. In Le Mans, they showed me painting robots, for example, not long ago. So even if the robots are not highly advanced, this is our storage facility. We have two systems. We have a drying machine and the silos. The dryer is like a robot. You have a certain amount of moisture. The moisture is measured. The temperature of the burners is measured. The speed also is measured. And according to the hygrometry of the grain that comes out, all is measured automatically, rather than a person doing all this. So it's very easy for maize, but not so easy for sorghum. Another interesting aspect is that sometimes, instead of wasting gas to dry the grains, we put them directly in the storage facility. And on our computer, we have a system which enables us to measure the hygrometry of the grains. We have sensors in the cells. We measure the level of grains, the amount of grain, the moisture of the ambient air, the moisture of the air above the grains, above the seeds. And according to that, we put the fans on or not. We either cool it down, or we dry it more, or we make it more moist. If we can sell the maize at 15% moisture, why not?
So we are now going to have a closer look at tractors, automated tractors, been marketed for years now in the US. Here is a mapping of the cover crop test plots in 2012. And thanks to embedded technologies, we've been able to do all these because it wasn't possible beforehand. And all the research work can be conducted on the farm without adding too much work. We have the self-ripping facility, we have the different cuts according to the place. Then you have the distinction that's being made with places, plots already seeded, those that have not yet been seeded, and that helps and do savings in terms of seeds, of course. As I told you before, and we have had for 7 years now, tractors. They are not fully automated. They are not real robots, but they are, let's say, semi-automated, and they are able to turn left or to turn right at the end of the row, and they know how to react, how to do a half turn, how to gain strength again, gain momentum, again, and start again working. So we've been able to improve the system. Of course, it hasn't yet been generalized by all manufacturers, but it will come. Another interesting point I wanted to raise, that spraying. Our sprayer is 30 meters wide, and late spring we use nitrogen fertilizers, and we did conduct studies with Green Tech. They sell sprayers that work along the line of an optimal band, measuring the content in nitrogen, and of course this helps to have adjusted spraying. And in fact, we try to improve, to upgrade the accuracy. That's a key point. We try to upgrade the accuracy of fertilizer usage. Combined harvester now, the technology is now available. You can have a look at all the detailed specifications of these machines on the internet, about their speed, about the flow. They can use, how they can organize troubleshooting, etc. So self-driving is, of course, essential when sowing and when harvesting, especially due to the fact that you may have dust. When you work at night, you have a lot of dust that is being spread or scattered all over the place. But thanks to sensors, to probes, you can follow the soil, the nature of the soil, maybe even rough, etc. And it helps to do a better work. And working around midnight is not what is more convenient, but at least it helps to have a friendly use of the equipment. There are other available technologies to date, especially talking about combined harvesters. You can, of course, tune your machine, your combined harvester. It can even clean the seed, and you may have greater or lesser losses at the back back of the machine, so you are able to gauge your machine, your combine harvester, to have a reasonable level of loss, and you try to optimize this level to have it consistent throughout the procedure, which helps to have a better harvesting results. And some systems tuning the speed or regulating the speed are doing it in order to better adjust to this loss problem. And the combined harvester is able to slow down, to speed up according to these values that you have entered, and that make it possible to optimize, in between inverted commas, the loss level, level of loss. These are large-scale adapted robots. These robots are rather well advanced. They are being manufactured by a startup located in India, and they are fully automated, fully autonomous, let's say. And we have large-scale fields. We do sampling every 3 or 5 hectares in our large-scale fields, and to be optimal, to get optimal values and results, we should be able to sample on the same site when you repeat the sampling. And if the sampling is not properly performed, it's going to cost you hell of money without yielding the requested result. Now, when you do soil sampling, you should perform at least 12 in order to get statistically significant soil values. And of course, in order to make things better, to improve the system, we can enter all the values. We have the GPS coordinates that are being embedded, and then the machine can do the sampling. And there is an added value, since this machine can do the can perform automated bagging. Now let's watch this short video in order to illustrate what I've just said. Slight technical hitch. Here it is. You can see some holes, and there are some flags showing that the machine was repeating the procedure on exactly the same soil, on the same plot, sorry, on the same place and site. And as you can see, the probe is being turned upside down, and the machine will do the sampling a few meters further out, or further away. Here it is. Someone came to show this machine to me, and the people found it difficult to use to some extent, and they wanted to have 3 machines for one huge farming holding. And so you have got someone working in a building and just or outside surveying what the machine is doing. And I can tell you that this machine, this type of robot, makes all the difference on huge plots, large plots, the one we have in the States, of course. Here is another robot. It's a drone, flying wing. It's something that's being used in Kansas, and This is nearly full 100% automation. We have a launching pad. The robot is going to take off and to have its own flight plan, flight route, flight path. It's able to correct, to remediate the flight path, and it can measure the nitrogen content and quantity or any other parameters. Some people use the pictures taken by the drone in order to see what is the quantity of corn or maize growing the following year, and checking the impact of these new shoots on the future yields. Could we watch a video right now? I went onto YouTube and I'm going to show them their own video. I don't think it's the right video.
Doesn't always come easy.
Le changement n'est pas toujours facile. Typical American landscape.
But every once in a while, something comes along that makes you see things in a whole new way. It changes how you plant and how you care for crops. So you have better plant health and higher yields.
Vous pouvez voir ici le plan de vol et ainsi de suite. Et donc ensuite les cartes qui sont récupérées par l'agriculteur, et donc ensuite tu peux faire des zones de prescription différentes
suivant ce qu'il veut traiter ou ce qu'il veut voir sur sa parcelle.
Donc voilà, c'est Agricole. Donc ça c'est une boîte qui est au Kansas et qui apparemment vend pas mal de...
So this company is based in Kansas and sells flying wings in Kansas and in the Midwest in the States. Robots and farms in the States, they are used for large-scale cereal production. Here is a map of the US, and you can see these large-scale farms. They are located in the Midwest. The more west you go, and the smaller the farming units. And of course, the use of robots is not the same in the small units. The people manufacturing agricultural equipment are able to produce what we need. Technologically speaking, they know how to do it, but it's not enough. I mean, what they have to improve is perhaps to know how to remediate any mistake, any error, and you have heard of trials that take place in the US. They are quite common, and people are often kind of reluctant and scared of the legal aspects and hassles. Now, the product is not yet perfect, fully completed, but it's going to be improved. Yet it's not always easy to point out or to screen the problems. That means we should perhaps use and integrate more sensors, more probes onto the equipment. As I was telling you, we have huge spaces. Sometimes distances are quite long. It may take you half an hour to go and fix an equipment that is faulty because the equipment, the machine is far away. This may not happen when you have someone driving the machine. This has, of course, an impact on the final yield, on the final cost. Another solution perhaps would be to have a real army, a real battalion of small robots. I've tried to get the feedback of the farmers in the States, and they tend to say that what should be best and what would be best is weeding, automated weeding system. Weeds are more and more weed killer resistant, so one major breakthrough would be to be able to target the weeds and to have a system, mechanical or not, to target the impacted leaf or foliage, etc. And if A plus B equals C, and if we can increase C or upgrade C, people will go for C to make it highly mathematical. Now, going back to the current situation, 1H is acting on very large plots and surface areas. We will need either highly performing, highly reliable large machines or battalions of small robots. Let's not forget that seeding windows or harvesting windows are always small, and we have to adjust. That's all I meant to say today.
Would you may ask some questions?
Bonjour. Donc en fait c'est une question pour Luc.
This question is for Luc. How much do automated combine harvesters cost? Or how much do autonomous tractors cost? Answer, I don't have the latest figures, but the combine harvester is going to cost $350,000, $400,000 plus the cutting parts at $500,000. How to justify this type of investment? Well, it's rather easy. We used an extra 4 combined harvesters this year because the crops were very good. May change according to the quality of the crop. Next question.
Moi, je voulais vous poser la question justement par rapport à ce que ça peut rapporter pour l'agriculteur.
What about the benefit and the profit to the farmers? Since the final aim is to have reasonable earning for the farmers. And what about the costs of produce in the short, medium, and long term? Don't you think that the farmers' earnings are going to decrease? Answer. Well, some farms can be highly performing, but the most performing farms are the ones that have the lowest cost, not the lowest, not the highest yields, but the lowest cost. The key factor, the key driver is the cost. And we know that the cost of farming produce is on the decrease. We all know that. What can we do? We produce commodities, so the differentiation aspect is not really something an added value to us. It's not something we are going for. We are not producing organic products, for instance.
Bonjour, donc pareil pour vous, Luc.
I understood that you worked with John Deere mainly. Can you work, or do you work with other manufacturers? Are they doing as well? Do they develop the same technologies and techniques or different ones? Answer. I do know of John Deere equipment. All the other manufacturers manufacture similar equipment. They may have different ways of doing things. Last spring, we were kind of frustrated with John Deere sales representative. We decided to buy a sprayer with someone else, Subtecas. I wasn't the one making the decision, but it's just because we were not able to embed it, to incorporate it to the John Deere platform. Due to the farm size, logistics makes all the difference. When the farm is small, it doesn't make that much difference. But when the farm is our size, you have to know of the quantity of spraying already performed. All this is being semi-automated with John Deere, which is not always the case with other manufacturers. That's why we went for them.
So my question is in English to Professor Blackmore. Like yourself, I like the smell of fresh oil and black smoke out of exhaust pipes and the screaming sound of hydraulic cylinders, hydraulic pumps. But on the other hand, those ancient technologies don't seem to fit well to your vision of smaller, many machines, robotic machines in the farm of the future. Whereas the whole sector is driven by those diesel engines and hydraulics. Could you share some thoughts maybe what are some missing links or in the enabling technologies towards robotization of future farms?
Okay, thank you. I think the question was really about power supplies, where we get the energy from. Well, fundamentally, what we've seen with the applying robotic theory or the thoughts of using robots is to significantly reduce the energy in the first place. So we do have a problem in agricultural robots which we call the energy density problem. So although we see a lot of the current robots running with batteries, lead acid batteries and so on, that's not really enough for doing, well, some are capable of doing very long periods. I noticed we've got a solar one at the back here, and I know the one in Sydney, the Ladybird, is running on photovoltaics. And according to them, it's fully charged in the morning when it goes out, and it's fully charged when it comes back at night. But the bits that are missing, really, I think, are we've been waiting for fuel cells to come along for many years. The electric car area is growing very fast with Tesla technologies and Tesla batteries and so on. These are all being developed outside of the agricultural sector. But when they become useful to the agricultural sector, I'm sure we're going to use them very quickly. But that doesn't preclude us from moving in this direction now. As I say, the most important thing is to reduce the amount of energy that we need in the first place.
I just have a question about how this will affect farmers. So there's farmers who own the farm, and then there are farmers who work on the farm. So in my opinion, a farmer is somebody who grows vegetables. But there is a difference in how we relate to the means of production. So how will farm workers be affected? I think we can say it's probably very negatively. We're going to eliminate farm workers with this technology. How will farmers be affected? I'm not sure. I think it's unclear. Philippe was saying we're about to transfer decision-making power from our electrochemical algorithms in our brains to synthetic algorithms. For the people who invent the technology and finance it, maybe the future is sunny. So what do we do? Do you think there's a responsibility to campaign for perhaps a global universal basic income to all these massive people that might be out of work?
Well, if I may start, one of the things that I've noticed is that as we are changing, as these new technologies come along, we are making a lot of assumptions. And if I may say so, you're making some assumptions that I don't necessarily agree with. So maybe we should investigate that area. One of the assumptions is that robots are going to come along and do away with people. I mean, that FAR concept to me is ludicrous. I just cannot accept that.
I didn't see any people in the videos, though.
Okay, that's my fault for not... Good point, thank you. I will try to make sure that I include this. No, the thing is, we have these scenarios already in place. Many of us will drive cars or motorbikes. There are parts going on inside those vehicles that are running by themselves. You don't adjust the timing. When first cars came out, you had to adjust the timing on the ignition for the car. That is done automatically. The amount of fuel that goes in. A lot of these things are done autonomously, and we are quite happy to give the car or the machine that type of autonomy. But the real control of the machine is still in terms of the person. Where we go, how fast we go, whether we turn left, whether we turn right. In my view, it's exactly the same with robots. So there are current machines out there now, variable rate technologies, on-the-go machines that have got our values embedded in the machines, and we give them the autonomy to carry out highly repetitive tasks. The idea that we press a green button, we go on holiday for 6 weeks to Hawaii and just check on our iPhone that the bank balance has been updated. No, that's not right. Farming is an art being replaced by science. And bit by bit, as science, as we have more understanding, we can optimize that science, but there is still always the art. So for me, when a robot is going to be used, we still have always got farm managers. Always, always, always. We would never have a totally 100% automated farm. A farm manager decides which crop to grow, where to grow, what type it is, what rates they want to have. How those decisions are then supported then will be through the cloud, through artificial intelligence, through models, as we do now. How they'll be implemented in the field will be done with robots, but it is only going to be representing what the farmer wants to do. One point that you then made about replacing people. Now, there are two main roles in this area. At the moment, we have maybe machine operators, tractor drivers. Years back, we would have many, many people working on a farm. And the big tractors have already replaced all those people. Maybe we had 20, 30 people on a farm, now we have 1 or 2 people. So the big tractors have already displaced all those people. I don't think that the permanent rural workforce will go down anymore. I think that we have reached the minimum amount, because whether we've got a tractor driver working on a tractor or a tractor driver looking after robots, we will still need those people. But the point you are making, if I may paraphrase, is what about the seasonal workers? And that is going to have a big impact. So, as you know, I'm from the UK. We are in a collective madness called Brexit, where people voted that we want to reduce the number of people coming into the UK, and that is then, of course, seasonal labour. But many of our vegetable farms, businesses, are predicated on seasonal labour, on bringing people in. And if that is then being stopped, then there is going to be a problem for farmers. But I think that the seasonal labour that is semi-skilled and highly repetitive can be replaced by robots. So those roles of people will definitely go. But the permanent workforce, I believe, will remain exactly as it is now.
And is there a responsibility for the seasonal workers?
Sorry?
Is there a responsibility to campaign for what happens to the seasonal workers?
That is a political decision, in my view.
To keep on schedule, we need to have only one question more. There was one here. Thank you.
Merci. Donc Florent Banquetel, conseiller viticole à la Chambre d'agriculture de Loire-Atlantique.
From the Chamber of Agriculture of Loire-Atlantique. Thank you for your presentations. Very high quality. Thank you, Professor Blackmore, for your impressive presentation and for the other presentations as well. My question is, we can see that man is going to have to adapt to robots. What about the landscapes? What about the environment? I work in vineyards, and the shape of the plots is extremely important. Now, is the landscape going to change? Hedges, the shape of plots? In France, we have the terroir notion, which is extremely important. Now, is there not going to be a new positioning of man within agriculture? So my question is Professor Janot, but I'd like to have the opinion of the other speakers as well. Thank you. This is an extremely interesting question. In France, we've had 1,000 years of peasant farming, people with children, with a job. They tilled the land because it was the only means they had to produce food and to breed. And they created the terroir, the landscape was the result of this economy and farming. From the 50s, with the Green Revolution, we restructured our landscapes totally to enable the machines to move about in the plots. We destroyed hedges, we filled ditches. The landscape of today is not at all what it was in the 30s in France. And the question you're asking is extremely interesting, because these technologies, what consequences are they going to have on the organization of the territory, on land management? This is going to have impacts, obviously. We can imagine that in some places we may not be capable of adapting all these technologies and to have a highly performing agriculture, because some places will be abandoned because we won't be able to reduce production costs, for example, in some regions. So there are some impacts at various levels and on various scales. It is difficult to assess them. Then the place of man in this technological world, where is it? What is it? With the Industrial Revolution, there were enormous productivity gains, but there's a lot of jobs that disappeared. The production of silk, for example, with worms, this disappeared totally because we invented artificial silk. This economy was extremely important, and it was destroyed in a very short time. Look what happened in Aubrac. We bred bulls and oxen to work all over France. With the energy and technological revolution, all this technology disappeared within the space of 10-15 years. And we see this in all sectors. Now, the revolution ahead is different. We're not talking about machines deploying the strength of men. They deploy the intellectual capacity of men. And little by little, the machines will probably replace these intellectual skills. of human beings. Now, we must not just look at the situation today. Let's look 50 years ahead. If you go back 20 years ago, well, there was no internet. Look at the revolution we've had with internet. So imagine new technologies within 50 years. So a lot of people believe that machines will take power. And some people go as far as saying that machines will chase away all human beings. We'll have to adapt. We've always adapted. But this is going to be challenging for very important balances. I don't know what's going to happen. This is a problem. Tomorrow, we'll go from 2 billion to 4 billion African people. So that region of the world will have to be fed. How are they going to adapt this new technology? Within agriculture, a type of agriculture with 60% farmers, they're going to go to 3% farmers. How are they going to adapt the new technologies to this transition? So what is at stake is extremely important and is not solely linked to technology. So the reply given was very complete. I'll go back to what I know, that is vegetable growing. Obviously, introducing a robot in a vegetable farm changes a lot of things because we are diversified. We had a lot of different crops, series, for example, lettuce. We have 15, 20 series a year. The vegetable grower has to be diversified. Nothing is standardized, and the introduction of a robot there, even if it is very versatile, requires a form of standardization and simplification. The producer has to anticipate the arrival of the robot. He has to change his time, working time, and production rates and so on, and the producers have to adapt. And they need to want to adapt. Some producers invest in robots and they say, well, no, I've already invested 25,000 to the robot. I want the robot to adapt to me. But with this type of mindset, we are bound to fail. We need the desire, the will to change our system. Even at our scale, we only have 2 to 3 hectares, and there's a lot to be done at that level to adapt. And the pair, the couple of the machine and the man. Now, are robots going to take the place of our seasonal workers? In our sector, that was a fear, but we are really at the other extreme, because to find seasonal workers to weed our crops on their knees during the whole season is very hard. We find them for one season, but they don't come back the year after. So that's where we are today. We have vegetable growers that are absolutely exhausted at the age of 35, and they stop the job because it's too hard. So robots would free the vegetable growers from those hard tasks or repetitive tasks, and they would have more time to look after their crop, to sell them, and perhaps the seasonal workers may become more loyal. So I do not agree with this idea, at least for my sector, for vegetable growing. Simon?
Just come back to the question on landscapes. It's a change in thinking again. What we've seen in the past with mechanization, with the tractors, particularly with the big tractors, is that we tried to make the fields bigger and take out the hedgerows. So what we've been doing is to adjust the environment to suit the machine. And I believe that is wrong. I think we're now at the stage where we can make the machines smart enough to work in the natural environment. So with the more intelligence inside the machines, with the smaller treatment areas, with being able to do just exactly the precise things that are needed, we should not change the environment anymore. We should make the machines smart enough to do what we want them to do.
Thank you, Simon. Well, I don't know you all, but I feel that finally we got more questions than answers. So this is amazing. We have a lot of things to think about later. Now we are having a lunch break, and we will come back at 2 p.m. Isabel,
thank you.
Thank you very much.
Thank you.
Okay.
Thank you. Thank you. Thank you very much. Thank you very much, Isabel. Thank you very much to our 4 speakers. As you say, it's lunch time. We're going to have a break. Please, before leaving the conference room, could you please leave your translation headphones on the table? You'll have them back for the second part, which be at 2 p.m. sharp. And it's entitled, How Robotics Work the Field. Thank you very much. See you at 2.